Hello everybody, this is BBoss1997 and welcome to part 2 of my capacitor videos. In this video I'll be showing you exactly what capacitors look like in real life. I only showed you theoretical designs in the previous video, the circuit diagrams and basically all circuit diagrams, so here I'm going to show you what real capacitors look like. This is a tiny little electrolytic capacitor off of a circuit board. Capacitors of this size are typically used for the element of time. Capacitors, although I didn't mention that in the previous video, they can also be used to introduce the element of time because you can charge them up and release them at certain time intervals. So there's a tiny little capacitor. Let's do a test on it. I have here a nice low voltage variable DC power supply, so that's what we're going to use to charge this up so I can show you how they work. Now, this capacitor is rated for 25 volts, but I'm only going to charge it up using 1, so I don't risk breaking it. So let's do a little charge here, just a couple seconds. Maybe yeah. Okay. That should do it. Now, let's measure the voltage. Oh dear. Should prop this up. That's good. So you can see that the capacitor accumulates charge. I only charge it up using 1 volt, but it says it has 4 volts in it. And rapidly decreasing because even measuring electricity uses energy. So there you have it. There's a tiny little electrolytic capacitor. Doesn't hold very much, but like I said before, it does hold charge. This is one of those flash capacitors I was telling you about earlier. This particular capacitor says it is about 350 volts, so it's a little bit more dangerous than the last one, but because it's small, it won't necessarily hurt me. So let's charge this up, not to full capacity, of course, but let's have a look. With this one, I can add a little bit more electricity because it is rated for a higher voltage. So let's try it. Actually, I can turn it up. Okay, that should be enough. Now let's measure it. This one will display a little bit more voltage than the other one because it can hold more. Alright, let's measure the voltage of this capacitor. It's pretty high. Yeah, it's a bit higher than the last one. Let's see if it'll discharge. Oh, I heard a little spark, but not much. Okay, so there's our flash capacitor. Now that I discharged it, let's see how much electricity is left in it now. About 0.30 volts. Yeah, see, not that much, because I just discharged it. Now, this capacitor is a little bit different. This is higher than the last one. This one's rated for 450 volts, so needless to say, I'm going to need a different power supply. For this one, I'm going to exchange my low voltage DC with that medium voltage AC transformer over there. It's about 400 volts. So let's charge this up and see how it does. Now, before we charge that capacitor, let's test our supply. On. Ooh, a little bit more than anticipated, but that's still okay because we don't have to charge it up to full capacity. For this, I will need this rectifier. Well, I'll call it a rectifier. For this, I'll need this rectifier because it's coming directly off of a transformer, and capacitors only work with DC, just like batteries, so I'll need to use that rectifier to turn it into half-wave DC It doesn't matter whether you put half wave or full wave DC in it, it'll charge no matter what. Before I proceed, I must warn you, I wouldn't recommend trying this yourself. It can be pretty risky sometimes. That's why I'm doing this on a non-conductive surface. Alright, so let's give this capacitor a little bit of juice. I have the positive side of the diode hooked up to the positive side of this, because it is essential to hook it up properly, because if you don't, it can cause damage and the capacitor may burst. So that's why on the diode there's a gray band that indicates the positive side. So let's charge this up for a couple seconds. I'll just do 1 second. Okay, that should be good. Now, let's take this end, touch it to this. You get a little spark there. It's not as much as it can do, but let's do it again. I'm not going to do it for long because it's a small capacitor. Let's do that one more time. So there, like I said, the capacitor charges up and releases all of its energy at once. Let's move on to the next one. I thought I'd mention that it is very essential for safety to keep the terminals of capacitors like this shorted, because they can actually accumulate charge from static electricity. Because all static electricity is, yet again, a potential difference. Anything can act as a capacitor with static electricity, including capacitors. So, if you have capacitors like this, keep them shorted out so that they don't develop any charge, so we don't have any nasty surprises. This is a larger capacitor, again, stored with its terminal shorted. And so why don't we hook this up. I'm not going to use the 400 volt source, I'm going to use the 1 kV source for this, because it is rated for higher voltage, but it's rated for 2000 volts, and I'm not going to go anywhere near that for safety reasons. Just because I just want to keep this pretty safe, because I just don't want to go up to 2000 volts. I'm again going to have to use this rectifier, so let me hook it up. Okay, let's do a discharge test on this. I have the rectifier behind the capacitor hooked up with proper polarity. I'm using insulated pliers for safety. This is a little bit higher voltage than the last one. And I have the negative hooked up to a metal plate, and the positive is being held in the pliers. So let me plug in the power supply and get started. Alright, let's do a test. Ooh, gives a bright snap. So there's our discharge. Let's do it again. Made myself a little smiley face there. So as I said before, I'm going nowhere near the maximum voltage of this, just for maximum safety. Let's do a few more of these discharges. Now, you might not be able to see some of the flashes, but that's because, see that? Yeah, you saw that one. Might not be able to see some of these discharges because the camera does have a shutter speed, and sometimes the flash actually escapes the shutter speed that this camera is running at. So, yeah, you might not see all of them, but you should see a few. So, there's our capacitor discharge. Right now, it's not very loud, but when you discharge it through some materials, such as materials that aren't exactly the most conductive in the world, it can get quite loud because it has to push through more. So, I mean, there's a basic rundown of some basic some of these capacitors. The principles were explained in the previous video, but in here I just demonstrated exactly what capacitors do. So, I hope you enjoyed this video. I wouldn't recommend trying this yourself. Just play safe, and I just hope you have a great day.